Today in math, we're going to talk about more division problems, and today we're going to focus on how do we know what strategy to use. We're going to begin today by watching an instructional video. We're going to start by listening to our success criteria.
Over the past few weeks, we've been working on representing the concept of division of whole numbers using multiple strategies. Over the past few weeks, we've been working on representing the concept of division of whole numbers using multiple strategies. The strategies that we have learned are partitioning, sharing, and the inverse of multiplication. We have also learned repeated subtraction and arrays in equal groups as ways to show sharing. You have also been asked to understand and use these words in your explanations of division. Today, you will practice determining which strategy is most appropriate when solving real-world division situations.
So just like yesterday, when we saw examples of candy bars, we realized it would take way too long to break off one piece at a time and share one at a time. That would take way too long. We don't have that kind of time. So today we're going to look at when we use division in real life, and we're going to determine which strategy would help you with the division problem. So now we're going to watch an example. We're going to keep listening to Mrs. Sousa, and she's going to show us some more information.
So far, we have learned 4 strategies for division. Today, we're going to begin practicing applying these strategies that we have learned to real-life situations inside of word problems. In order to decide which type of strategy is best, let's quickly review the strategies that we've learned so far. Beginning with repeated subtraction. 24 divided by 3 tells us that we are subtracting groups of 3 and deciding how many groups that would create. 24 subtract 3 gives us a difference of 21. With 21, I'm able to subtract 3 again. 21 subtract 3 is a difference of 18. I'm still able to subtract 3. 18 subtract 3 gives us a difference of 15. 15 subtract 3 gives us a difference of 12. 12 subtract 3 gives us a difference of 9. With 9, we're still able to subtract 3. 9 subtract 3 gives us a difference of 6. 6 subtract 3 gives us a difference of 3. And finally, 3 subtract 3 gives us a difference of 0, which means we are out of items to share. When we look at these repeated subtraction equations, we will count how many times we were able to subtract. 1, 2, 3, 4, 5, 6, 7, 8. I was able to create 8 groups of 3. So according to repeated subtraction, my quotient to 24 divided by 3 would be 8.
All right, we are going to jump into a breakout room to discuss what you notice about Mrs. Sousa's example. What do you notice about her example? I want you to turn and talk to your partner as soon as you get into your breakout room.
Then we moved on to learning about equal groups. With 24 divided by 3, we can look at this as creating 3 groups. Then we would place one item in each group until we got to a total of 24 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. When I count the items in one group, I'm able to see that there are 8 items in one group. So my quotient for this strategy is the same as the previous strategy. When we're looking at drawing with arrays,
Okay, so now Mrs. Sousa has described how we can divide using equal groups. If we have 24 items and we're going to break them into 3 equal groups, we know there will be 8 in each group. Now we're going to listen and focus our attention on how to use an array to show division.
We put our objects into rows and columns. 24 divided by 3 tells me that I should create 3 rows. 1, 2, 3. And I'm going to place 1 additional item in each row until I get to 24. We started at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And when I count, I am able to see that there are indeed 8 items in one row. So again, our quotient is 8. As you can see, passing out items one by one does take some time. So partitioning is something that can help us move a little bit faster inside of our work. We know that we need to get to 24 items. So instead of passing out items one by one, we can look at our groups as buckets and we can drop a few items inside of the buckets until we run out of items. So I know that 24 is an even number, so I'm going to try to divide by an even number. But 24 divided by 2, I think 2 is still too small. I might try to divide by 4. Let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, that gave me 12 items. So 4 worked out pretty well. I know that I still need to add more to get up to 24, so I'm going to try to do 2 this time. Let's see if it works. You know what? That would be smaller than 12. I'm going to try 3. So 4, then I'm going to add 3. This gave me 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so when I added 3, that got me up to 21 because I added 9 more. I need to get up to 24 and I'm at 21. That's only 3 away. So I could put 1, 2, 3.
Okay, so Mrs. Sousa is showing us how partitioning can really save us time. You saw with her array, it takes a long time to count 1, 1, 1 at a time. So as we get faster with division, we realize we can partition and put chunks into groups and count up to our dividend. We are going to go into Seesaw together now. Please click on Activities, Assign to Class folder, Blue, Math, and our task is called Division Strategies in Word Problems. Today you're going to see word problems and you have to pick a strategy that you think would help you solve the division equation, just like Mrs. Sousa's teaching video. Please click Add Response. And open your assignment. Okay. On slide 1, we have a word problem with division, and we are going to read the problem, determine which division strategy would make the most sense, and then we're going to solve and answer the question. We're going to read the word problem, and then we're going to think about what strategy would make sense for this example. Cecilia is planning a party at her apartment clubhouse. Her guest list has 32 people on it. There are 4 tables in the clubhouse. If she wants an equal number of people sitting at each table, how many chairs does she need to put at each table? Let's read it again. And I want you thinking about our strategies that we know. We know about repeated subtraction, partitioning, arrays, or equal groups. I want you to think about what strategy we could draw that would make sense for this problem. Here we go. Cecilia is planning a party at her apartment clubhouse. Her guest list has 32 people on it. There are 4 tables in the clubhouse. That looks important. If she wants an equal number of people sitting at each table, how many chairs does she need to put at each table? So my question asks, how many chairs does she need to put at each table? So right now, I'm closing my eyes and I'm imagining her party. She has 4 tables. And she wants to know how many chairs does she need to put at each table. Can you picture that in your head? I want you to think about which strategy we could use that would make sense. We're going to go into our breakout rooms and talk with our partner and determine, is it equal groups? Is it an array? Is it repeated subtraction or partitioning? Which one do you think makes the most sense? Okay, so you have had a chance to talk about which strategy would make sense for this type of world problem. So I'm looking for a friend who can share out what strategy they think they might use to help them solve this problem. Gloria, go ahead.
I think equal groups.
Okay, so I think a lot of us were thinking about groups because the problem tells us that there are 4 tables. So when I close my eyes, I'm picturing tables. And I think that makes sense that you might draw 4 tables or equal groups. Then you might think about how she has 32 people and she wants an equal number at each table. So I jumped into the breakout room with Day, and I remember Day saying we can skip count. Day is absolutely right. We can use skip counting. So maybe we could start with 5 at each table. And let's see if 5 at each table gives us up to 32. So I'm going to skip count like Day suggested. And I'm going to start with 5. 5, 10, 15, 20. Okay, that's only 20 guests. That's only 20 people. And I know that Cecilia has 32 people coming to her party. So 5 is not enough. I'm going to take each group number and go up 1 and see how many guests that would be. Let's try skip counting by 6s. 6, 12, 18, 24. Okay, last time I only had 20. Now I have 24 people. I'm getting closer. I'm getting closer, but I still don't have 32. I see Cecilia wants 32 people at her party. So that's still not enough guests. Still not enough guests. I want you to go back into your breakout room and I want you to figure out how many guests are at each table. We tried 5 at each, then we tried 6 at each. Can you help me figure this out by using equal groups? Can you determine how many guests will be at each table? I'm going to send your invite to your breakout room, and we will talk about this with our group. Okay, I need your help. I have heard student responses saying that there are 7 at each table, 8 at each table, or 9 at each table. So we got to figure this out together. Let's start with 7 at each table. If we put 7 in each group, what would the product be? If we have 4 groups of 7, what would the product be? Who can figure that out and share with the class? 4 groups of 7, what would that be? I already see some friends who know. Honesty, what would that be?
28.
Okay, that's only 28 guests. Thank you, Honesty. So 7 guests at each table, not enough. Let's check to see about 9. Let's put 9 chairs at each table. Let's do 9 equal groups. If we put 9 chairs at each table, 4 groups of 9, 4 groups of 9, what would be the product? Who's got that and can share it with the class? 4 groups of 9. Nick, what would that be?
36.
36 guests? Okay, let's check. Uh-oh. She says 32 people are coming. 36 is greater than 32. So that's too many people. That is too many people. Okay, the other answer we heard was 8. So we're going to guess and check for 8. 8, 8, 8, 8. Who can check our work? Who can check our work? Find out, is that the equivalent amount that Cecilia would like to invite? Who's got the product? Gloria, go ahead.
It's 32.
It's 32. That's the amount we need. Cecilia has 32 people on her list. There are 4 tables. She wants an equal amount. Let's check that we have equal groups. Okay, I think we're good to go. We have equal groups. And how many chairs does she need at each table? I am ready to type my answer. We know she needs 8 chairs at each table. Just like Mrs. Sousa taught us, we need to answer the question after we show our work. We need to answer the question after we show our work. You may do that now. Your job is to complete slides 2 and 3 and reflect on your learning. Then you will turn it in, please and thank you.